Hi, welcome everyone to my YouTube channel. Recently, I have been actively posting content on LinkedIn. I have completed some of the major core subjects of data science, artificial intelligence, and machine learning course from IIT Bombay. It has been a great journey so far. I have come to know about the insights, how to think into a problem of no given a very huge data at a scale, and they have no been successful in building a mindset rather than thinking around only the concepts or the theoretical part. So given a problem, the whole idea is to create a mind map how exactly that problem we one should go about. Okay. So I'm very close to completing that whole stuff. Okay. And the journey so far has been enlightening, as I said. And no, I just want to share my learnings, as no, I have spent considerably huge amount of time learning these concepts, and I want to spend some time explaining those subjects, those stuffs in great detail, so that if you want to be part of that journey, if you are feeling no of to be missing out, because everyone is talking about, but no, we are mostly talking about the applicative parts of AI, applicative parts of machine learning, and not about how to build things from ground up. Okay. It is important to understand the differences between what application of machine learning AI is, and how you can build it from ground up. They both are entirely different things, and they both need entirely different skill set altogether. Okay. So I will try to cover all of the things probably in a span of some months. Okay. These will be probably more mathematical, more statistical, and hands-on. I will not talk about. I will definitely talk about theory, because theories will build your intuition. How exactly things work inside, the internal how the internal logistics work inside a machine learning algorithm. And then finally we'll try to build some hands-on applications where we will see the actual flow of how mathematics is binded to these models, and if needed, how can you tweak or probably enhance these needed your domain and other expertise, right? So, as I said, this is a huge undertaking that probably I will cover AI, ML, and data science. As I said, this is a wild topic, um, uh, changing every day. No, I spend considerable amount of time reading every day to make sure I catch up with things. And but what I observe is the foundations are all pretty much the same. So, without wasting much time, let's see how the things would be looking like. So, exactly as I said, I will be covering uh, the hands on aspect of it. So, we will start with, say, probably the curriculum. Okay. How things would look like. Okay. You can say what would be covered, right? Um what would be covered? Would be covered in this. Okay. And then we'll go into each topic detail, uh, of how things look like. uh, when I say this, probably you should understand, it's a huge topic in itself. When I say AI, machine learning, and data science, these three are different umbrellas. Okay. But when we talk about when we take a practical pragmatic problem, it all comes down to mingling all these into a single thing, and no talking about them in a single mindset, so that no you are able to apply all these to solve a given problem. What I will do is, probably let's go through the curriculum. Okay. I will just talk about it a bit, okay, how the curriculum would look like, okay, how the what would be the syllabus, okay, and what exactly will be covering as part of this thing, the whole course, okay. So I prepared a small doc of what exactly we'll be going through, okay, and we'll see of it very quickly, okay. So this is it, okay. So this is the overall machine learning curriculum what we'll be seeing, and just to give you an idea, you can see we'll talk about basic mathematics first, okay. Basic mathematics will start from statistics for AI and machine learning, which will have foundations. By foundations, I mean how do you measure something in mathematically, types of measurement like cardinal, ordinal, and different aspects. Then we'll look into probability rules, basic probabilities. We know that all machine learning models are probabilistic in nature. We have been hearing that, but we'll look into that in a bit detail. We'll look into different distributions in statistics to represent the data. We talk about distributions, and that distributions may fall into various categories: normal distribution, uniform distribution, Poisson distribution, exponential distribution, and so on and so forth. So we'll go into detail of each one of them. We'll try correlating of how this theoretical thing, what we are theoretical and mathematical thing, correlates with real machine learning examples or libraries what we will use, okay. There are lots of machine learning libraries out there. TensorFlow, we have other computer vision libraries as well, but no, the thing, or you can say the basic foundation, is common among all of them. They work on the principles what have been formulated using these mathematical rules, okay. We'll go into deep detail about that, and then we'll go into other part of statistics which we call as hypothesis testing, confidence intervals, t-test, and chi-square test. There are multiple types of tests we'll be looking into, okay. Then we'll start with a basic model, probably a linear regression. We'll look into the matrix concept of how exactly matrices are used to do the modeling of the data patterns, okay. So the whole idea is to learn the data pattern, right. Machine learning is about learning the data pattern. Add to learn the intelligence is called AI, right. Where you have learned something and you want to leverage that learning to make it bigger, or probably serve something bigger, okay. So that is where this whole thing comes into. Then we'll go into Python essentials. We'll look into how exactly data science problems can be solved using Python. We'll look into some parts of databases, big data, and cloud. Okay, data pipelines, featured engineering. Then we'll move into the machine learning part of it. So in machine learning, there are multiple branches: supervised, unsupervised. Then there is a semi-supervised, then there is self-supervised, okay. Those are advanced topics, but we'll be covering all of them in detail. In supervised learning, we'll look into regression, decision trees, SVM, and kernels. These are some examples. I can cover a lot more than what is mentioned here, but this is just an idea what exactly how we will be going. In unsupervised, we're looking into clustering. We're looking into how we solve problems using the PCA, principal component analysis. We'll look into then we'll move on to model optimization, where we'll learn into bias variance trade-off, regularization, very important, you can say, tool set for machine learning real-time model performance, tracking real-time machine learning model performance, okay. How to leverage these concepts to make your model more robust, okay, and no get away with a lot of outliers, right. Then we'll move into an important aspect of AI, machine learning, which is called deep learning, and from deep learning we'll move on to generative AI. Okay, in deep learning we'll start with neural networks, how back propagations works, convolution neural networks, recurrent neural networks (RNN), and long short-term memory (LSTM). Okay, these are the historical, you can say, historical models, or you can say intuitions that have been more or less the basics of of how exactly the model architectures like transformers, the vision transformers or the vision language models have been invented. So you need to be aware of all these basic functionalities or basic concepts of what was the timeline, how these all things came into picture. Okay, there is nothing is invented in one day, right? Modern machine learning or AI models like transformers, mostly based on transformers, and even more advanced ones are probably have evolved from these uh, base models, I would say. Okay, so you have to have a very solid and solid understanding of all these when we jump to the advanced architectures. In advanced architectures, we will learn about transformers in depth. Okay, we'll cover everything in detail with hands-on coding examples, autoencoders, generative adversarial networks, which we call GANs, right? Then we'll move into a bit of Gen AI concepts, right? Where we'll look into racks, vectors, knowledge graphs, RLHF, and all these stuffs. Then we'll look into computer vision. We'll start with the basic. We'll start with the basic image processing and signal processing stuff like filtering, edge detection, superpixels, and all these morphological processing in the images. And then we'll move into more of advanced AI computer vision like object detection, segmentation, vision transformers, and all. Then we'll start looking into the deployment part of the models, like how exactly we will deploy these models onto some cloud-based environment, right? We'll look into Docker, Kubernetes, cloud ecosystems, inference pipelines. We'll learn about transfer learning, fine tuning, and other aspects of no large language models. As I said, this is I literally got the limited time to prepare this, but this gives you a whole lot of idea what all things we will be covering overall. The whole focus would be around mostly around the more advanced part of stuffs, right? Like as I said, we will be more of looking into the natural language processing. Okay, then we'll look into computer vision, right? In computer vision, we'll look into especially the modern architectures and all modern architectures, right? So it will be lot of things. Okay, as I said, a long way to go. It will take some time for me to gather information for you and no bring in the best possible for you, so that no you get the hands-on experience for all of this what I just mentioned. Hope you will enjoy all this. Okay, I have been spending quite some time learning about these topics, especially the modern mechanism of artificial intelligence, like building agents, AI agents, and then modern computer vision systems. And I would be glad to share all of this in detail with you all. Okay. Um, Stay connected. I think a lot of information will start coming. Okay, and follow, subscribe, no, to get in more information, and keep watching and keep giving your feedback and support. Okay, thank you.